Welcome. And today we're going to do another lesson in Pre-Calc Trig. This is section 1.2, angle relationships, similar triangles. A couple of things we're going to take a look at. So this is, again, a kind of a review of geometry, but in case you're rusty or you need extra help, we'll go over a few details. So what I have here is I have two parallel lines. And these two parallel lines are being cut by what we call a transversal. So these lines are parallel, and this is called a transversal. It's just a line and an angle. It could be straight up and down. Anyhow, it's a transversal. And it cuts those two lines. So the first thing we notice is that this angle and this angle are equal, and they're called vertical angles. And you can think of this as a V vertical, and this is coming this way, and this is coming this way. So these two V's are intersecting each other. And so these two angles are equal. Okay, and if we were to continue this up, this angle, this angle, this angle, if you notice, this looks like a 7, this looks like a 7. This is equal. So these two angles are equal, they're corresponding to each other. These are called interior angles. But, you know, regardless if you know the name, they're going to be equal, and this will be equal. So it kind of goes up, ding, 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 up, like a snake, just kind of snaking its way up here. Likewise, when we draw these with two lines, these two angles are vertical. These are the same, and these are the same. It snakes its way up. Okay, so that's kind of an idea how vertical. If you basically don't know exterior angles, interior angles, if you just know vertical angles, you can get yourself around this triangle or these transversal problems pretty easy. Let me draw another line through here. Okay, so another thing we're going to look at is one other thing that's kind of interesting. Let's label these angles just for the heck of it, make it a little bit easier on ourselves. Let's call this 80 degrees, and therefore this angle right here and this angle are vertical. Actually, let's call this 100 because it looks a little bit bigger than 80. And this would be 100. This would be 100. And this would be 100. Let me make this a little bit bigger so it's a little bit easier to see. Here's my transversal. Okay, so I'm going to call this 100, 100, 100, 100. Well, from supplementary angles, we know that this has to be 80, right? And therefore, this would be 80. But these angles right here are also supplementary, and they add up to 180. These add up to 180, 180, 180. Whole circle, 360. So you can kind of see, this is 80, 80, 80, 80. It's a little bit easier to see when you actually put numbers in here that you can see that these are kind of snaking them away around here. And you got your angles, okay? But one other interesting thing is if you take a look at these two angles right here, this angle, and this angle right here, this one right here, and this one right here, you can see they equal 180. So these two angles, these angles inside here, we call these interior angles, will equal 180. And if you look over here, the same holds true. They're 180 degrees. these two angles inside here, inside this little pentagon or parallelogram or whatever you want to call it, are equal. So let's solve some problems. Knowing this information, let's see if we can solve something, make it kind of an interesting problem. Okay, so I'm going to do this example in the book. Example 1. This is on page 11. You have two angles here, and you have a line coming down this way. This angle is 1. This is 2. This is 3. This is 4. And they told us that this angle right here is 3x plus 2. And this angle right here, they told us is 5x minus 4. And we want to find all, minus 40. We want to find all these angles. So let's dig in and get it. Well, let's see, first of all, what the relationship is. Bing, bing, bing. So we know angle 3 and angle 4 are equal. Angle 3 equals angle 4. 3 and 1 are vertical angles, so they must be equal. So 1 and 4 are equal. Angle 1 equals angle 4. Therefore, 5x minus 40 equals 3x plus 2. And then all we got to do is solve this. Bring the 3x over to the other side. Bring the 40 over to the right-hand side. And calculate. This would be 2x equals 42. And x equals 21. Now, that's not the angle. That's just the value of x. So now we want to put, excuse me, how do I get rid of this? Okay. So now we want to find out what this angle is. We're just going to replace this x with 21. So angle 1 is 3 times 21 plus 2. What would that be? 63 plus 2 is 65. So that angle right there is 65. Finding this angle, angle 4 is, should be the same, huh? Let's double check it and make sure. This would be 105, take away 40 is 65. I mean, it's just kind of obvious. Now, if we don't, kind of going around here real quick, let's see if we can find the other angles. Okay, so this is 4. We said this was 65, therefore this would be 65. Therefore, this would be 65. They're opposite each other right here. So we know angle 3 is also 65. And we know angle 1 is 65, but what about angle 2? Well, angle 1 and angle 2 are supplementary. They add up to 180. So angle 2 is going to equal 180 minus 65. See, 5 from 10 is 5. 6 from 7 is 1. Should be 115 degrees. These two angles should add up to 115. And now we found all the angles. Angle 1. So on your paper, when you do these papers, you want to make sure you put your name on the paper and enter your papers through Canvas. So you can download them. Make sure you download or use the inbox on Canvas. Okay, so 65, 65, 65, and then this one's supposed to be a 5, and kind of a little sloppy there. And then this would be 115. All right. The other interesting fact is, and this again you probably know, is all the angles of a triangle will add up to 180. So if this is 20 degrees and this is 80 degrees, this would have to be 100, and then so this would have to be 80. They have to add up to 180 degrees. A lot of times we have a right triangle, which makes it easier. So we know this is 90. Draw it a little bit better. So then these two sides would have to add up would have to add up to 90 also to make the 180. So we could call this 30 and 60 or whatever, because then they're going to add up to a right triangle. So let's try another one of these interesting little problems here. Here they give you one in the book. It's pretty simple. You have a triangle here. This is 61, this is 48, and this is x. So we could write this in equation at form as 61 plus 48 plus x equals 180. You can add these together, that's 109. You might not be as formal, but this would be a kind of a formal way of doing it. Minus 109. That would give us 1 and 71 degrees. So we can find that answer real quick to the problem. Okay. So that should be too hard. The other relationship is what we call a similar triangle. Triangles are similar if all the angles are the same, but maybe the sides are different. They're not really equal to each other. They're not congruent. If we want to show they're exactly equal, we put this symbol here, and that means they're congruent to each other. But if they're similar, we just use that little thing. So these are basically similar triangles. They both have a right triangle. Maybe this angle right here is 30 degrees, 30 degrees. This angle right here is 60, so that would give us 180, 60. And let's suppose we knew this side right here. Let's call this side 3. And this side right here was 5. And maybe this side we even know is 4. The 3, 4, 5 right triangle. So maybe this side right here is 12. And we're trying to figure out what is that side? What is the longest side, the hypotenuse? Okay, well, without using Pythagorean theorem and all that, we can set up just a simple little proportion. 5 is to 4 as x is to 12, right here. So let's write that out a little bit fancier. And then all we got to do is solve this. To solve this, we're going to just multiply cross products. 4 times x, 4x. Product of the extremes is equal to the product of the mean. 5 times 12 is 60. Divide both sides by 4. X is 15. And it should come out to 15. So we were able to find this missing side right there. So that's how we can use these kind of ideas. Another way we could use it is looking at this example in the book. They have this drawing right here. And they have this drawing right here. And the drawing should be similar, and they're not probably the best. So they drew one line here saying this is 45. So we know this is also 45, right? And they drew this with 2 lines and this with 2 lines. So this angle right here said was 104. So we know this angle right here is 104 if these are similar to each other. And finally, they use 3 lines here to designate this angle and that this is similar to it. And this was 31. So this has to be 31. So if we give them letters, we know B has to be 31, and we know N has to be 45, because they correspond to each other. Okay. Now, are they going to make it a little tougher for us? Yeah, yes, they are. So let's try a little bit harder problems and see if we can figure these out. Okay. So one problem that gave me a little difficulty was this problem number 9 in the book. And this is on page 15. And when I was looking at this problem, I had a lot of difficulty doing it at first. I saw this as 9x plus 12. And this angle right here was 6x plus 3. But what I didn't notice is that this angle right in here, I thought when they wrote the 4x minus 3, it was on the outside. And I didn't realize that this line came in here. So it was a really difficult problem to do when I was trying to figure out how to do this. I did come up with answers, but they weren't matching up the book. Then I realized that the arrows, these two angles were inside, this one's outside. Okay, well, we know the angles of these have to add up to 180, okay? But how are we going to do this when we kind of calculating this thing out? So let me show you an idea I had. This angle right here, this first one, we'll call 4x minus 3. And this angle right here, 6x plus 3. But they have to add up to 180. But what is this angle inside here? What is this? So these two angles are supplementary. That means they have to add up to 180. So this angle inside has to be 180 minus the 9x plus the 12. But we want to make sure we put that in a parentheses. 180 minus the 9x plus 12. Now let's see if we can solve this. Well, we can subtract both of these from both sides, 180. So now I got 4x minus 3 plus 6x plus 3. And this cancels out this, but we're going to make this 9x minus 12 equals 0. And I distribute that. Now we're combining like terms, 4x, 10x, and negative 9x make x. Negative 3, positive 3, they cancel. Minus 12 equals 0. Bring the 12 to the other side, x is 12. So now we figured out what x is. That didn't give us the angles, but at least we could get a head start. So this angle, they don't really have a measurement on it, but this would be 4 times 12 minus 3. That would be 48. Take away 3 would be 45. So chances are, if this is a right angle, we aren't sure. It didn't say it was a right angle. Okay, so this is going to be 6 times 12 plus 3. It's going to be 72 plus 3 is 75. Okay. And then this angle right here inside, well, we can do it a couple different ways. We could put in 180 minus 9x plus 12, but let's just add these together, 10, and this is 11, 12, and subtract from 180. The remaining angle has to be 60, because 45, 75, and 60 add up to 180. Let's check our answers. Number 9, and I didn't get it right. What am I doing wrong here? Oh, because I wanted to find the angle inside is 60. I wanted to find out the 9x plus 12. Okay, so let's see if we can figure that one out. Well, we know x is 12, so 9x, 9 times 12, plus 12. That would be what, so you have to be kind of careful. But they didn't ask for the angle inside, they asked for the angle outside. 108 plus 12 is 120. And that's where they got their answers. Okay, so that would be 120 degrees. And you might reason this out a different way. It's quite possible that you could do this another way. I'm checking my answers here and make sure. So that's why sometimes if you're in a hurry and you got the answer and say, oh yeah, this is 60, that's not really right. This 60 and the 120 obviously make 180, but this was the angle we're looking for right here. Okay, so, be careful when you're doing this. Okay, one last problem that I thought was, well, maybe two last problems. Okay, one problem I noticed was 63. Looked like an interesting problem. Let's see if we can find it. There we go. And of course, you want to do other problems too, but I picked these out because they seem kind of interesting. And there was something like this. I'm sorry, the drawing isn't that great. There we go. Maybe a little bit better. There we go. Okay, so they gave us some dimensions here. They said this was 50, this was 100, this was 120 from here to here, and this was X. Okay, so we were trying to figure out what are the dimensions of this thing. Well, what you want to do is break this down into two triangles which are similar. You've got the small triangle that's 100 by 50. Okay, and then you've got the total triangle. Let me do this in red. You've got this triangle. Draw it over here, which is similar to that one. But this dimension here is X, and this dimension is the sum of these two numbers. This is 100 plus 120. This is 220. The distance all the way across. Now you have two similar triangles. So sometimes you have to pick them apart. And now we can find out what X is. 50 is to 100 as X is to 220. Okay, and then we can calculate this. 50 times 220 is 1,100. And 100 times X is 100. I should say 11,000. Let me put another zero there. And this would be 100X. And so if I divide both sides by 100, I get X is equal to 110. And that's this dimension right here. It should be, see how this was half as big? This should be half as big. So we got our proportion there. So a lot of these angles are proportionate, but when you see a problem like this, it does look confusing. Break it into two parts, the small and then the big. Okay, another problem that comes up is 57. 57 says the height of a tree casts a 45-meter long shadow. At the same time, the shadow cast by a vertical 2-meter stick is 3 meters long. Find the height of the tree. So again, you want to interpret this as a drawing. That would probably help you. So here's how I would draw it. Okay, you've got this tree here, and it's casting a shadow. The shadow's coming right here's the sun casting a shadow, and this shadow right here is 100. No, it's 45. Where did I get 100? 45. This is a right triangle. So it's got 45 right there. And we don't know the height of the tree. That's where we're trying to find out X. But then you got this little stick in the ground, and the stick is 2 feet. And it's casting the shadow. And the casting the shadow is 3 feet. So if you draw a picture like this, now you can see the reference. X is to 45 as 2 is to 3. The side is to the side as the bottom is to the bottom. Okay, and then we can just solve this real easy. 3x equals 2 times 5 is 90, and x equals 30. And this would be 30 feet high is the tree. So I hope this helps, and stay healthy, and I'm going to try to sign off. And